Hey everyone, welcome back to the channel. So in this video, we are going to discuss 9 best practices about microservices, which you can follow to build scalable, reliable, and maintainable systems. So whether you are designing systems for millions of users or you're building a large-scale system, just getting started with distributed systems, right? So these 9 microservices best practices that I'm going to discuss now will definitely help you in planning out the entire implementation, all right? And you can build your microservices the right way. So in the next 10 to 15 minutes, I'm going to explain you 9 best practices about microservices that is going to change your thinking, the way you think about or see about the microservice. Give me 10-15 minutes, so you're going to learn a lot of things in this video. So let's start with the number one first. So the first one is using separate data stores for each microservices. Now, what do you mean by this? So each microservices ideally, have its own private data store. So no sharing, nothing. Why? Because coupling services through a shared database. Let's say this service is a shared database. If you have a shared database, it means you are not decoupling the logic. So you can imagine like this. Imagine there is an order service and a user service. If both the services access the same users table, let's say there is a users table here, all right? They access the same users table and modify the data, and any schema change by the user team could break the order service unknowingly. And it's usually ideal have separate databases, even if it's the same engine like Postgres or Mongo. Even if the engine is same, you can plan for different database instances. So let the services talk through APIs or gRPC, whatever it may be, but not the tables. All right. So this is the first best practice that you can adopt. Now let's move on to the next one. So our second best practice is keeping the code at a similar level of maturity. Now, what do we mean by this? So this is about technical consistency, basically. Okay. So if one services uses legacy Java 8, let's say this uses legacy Java 8, your team is dealing with multiple runtimes, frameworks, and even libraries, which can lead to cognitive load and cognitive complexity, and maintenance overhead also can increase. For example, another service or another team is using Spring Boot, a latest Spring Boot 3.0. Now what can happen? Now if you upgrade logging system to, let's say, OpenTelemetry in one service, but another is still using the Log4j. Now debugging an issue across this service cluster or service architecture will become a little bit tricky. All right. So it's always advisable to keep all the services at similar level of maturity and keep the versions up to date. Okay, as much as possible, and keep them closer. So that was about the second best practices that you can follow. Now let's move on to the third one. So this is a pretty important one. Why I will discuss. All right. So the third one is to have separate build pipelines for each microservices. So ideally, what should happen? Every microservice should have its own CI/CD pipeline. All right. So this allows the teams to build, test, and deploy independently. Because just think of an example. Imagine you have an e-commerce application. All right. So you have a cart service and you have an inventory service and a payment service also. Let's say here. So if the cart team pushes a new feature or new change, they should not have to wait for the payment team or the inventory team to finish testing their work, right, in order to ship their feature. So with separate pipelines, each team can deploy with confidence and with a limited boundary, right, and with minimal dependency over another unnecessarily, and even without risking unrelated services. So that's why having a separate build for each microservices makes the entire CI/CD and deployment pipeline smooth and seamless. All right. Now let's move on to the fourth one. So this is another an important point. Now let's discuss. All right. So the fourth point or fourth best practices we have with us is assigning single responsibility per microservices. Now what do you mean by this? So this is basically this service single responsibility principle is from the solid principles that we have, but it is applied to distributed systems. Let's say, right? You can think of that way. So what does it state? Each service should focus on one domain or one functionality. For example, if we have a auth service, microservice, let's example, okay, let's say it handles the user authentication, login. It also sends emails, welcome emails to the users. It is also logs the user activity. So it's doing too much basically. So rather we can split the microservice into two sub microservices, like an email service and a user activity logger service, right? So the user activity log service will log the user activity. The email service will handle user login and send user login registration and send the emails and whatnot. So this, by separating two different sub microservices, this leads to better scalability and makes your services easier to maintain and test and work with. Right. So this is a quite important thing that we need to uh, think about and implement in our microservices architecture. The fifth point we have with us is to deploy in containers or deploy the services into the containers. So this is quite nothing new here, right? I mean it's a thumb rule in today's development world. Docker is your best friend here. Microservices run best when they're containerized because containers encapsulate everything, right? Starting from the runtime, dependency, config, everything is containerized to a single package or single container. And then you can, for example, let's say you can spin up a notification service. This is a notification service. You can spin up a notification service container in staging with exactly same setup as the production. So no more it works on my machine stuff, which Docker itself says, right? So you also get seamless scaling using Kubernetes or ECS, right? Also the containers integrate perfectly service meshes like ISTIO or ISTIO for advanced routing and telemetry collections, right? So that's why deploying your services into containers, you always should think about that instead of deploying manually, instead of directly pulling the code, manually updating servers, manually running a server, manually running a production grade server in the machines. That is not desirable. That is not recommended actually. Next thing is the sixth point we have with us is the designing stateless services allows services to scale horizontally. Now how? Now if your servers or services store state in memory, let's say in its own memory stores the service, you lose the state if the pod or services crashes, right? Rather than storing the state in the memory itself, what we can do, we can push the state or memory data to a Redis or a document store which is distributed or it's separate, right? So which will make both the services stateless completely. So this is basically essential for load balancing and zero downtime deployment. So we should think about making our services stateless as much as possible because it also helps scaling the services horizontally as the load on the server increases. This is a very important point. Now, the seventh point that I'm going to discuss is again another crucial point which we usually overlook when we are starting with distributed system. We usually overlook this concept. Now why? Now the seventh point is domain driven design. Now what do you mean by domain driven design? So domain driven design helps you identify service boundaries. Focus on this point, service boundaries that aligns with the business logic, not just the technical layers. Technical layers is in control load, services, routes. These are the technical layers. It's not only about that. We should encapsulate and set boundaries uh, of the business logic in a particular domain. It should be domain driven. For example, in a ride sharing app, let's say we are building something like Uber, we'll have distinct domains like trip management is a domain, driver matching is a domain, billing is a domain, right? Each of these should have its own bounded context and service. For example, it should have its own folder having controller, service, routes, and repositories. And similarly, driver matching should have its own controller, service, routes, etc. So this improves team autonomy and reduces coordination overhead. And each of the team or even the members of the single team can independently work on these modules without affecting the functionality of other. Okay, and it will be easy to maintain the code on long term also. This is what domain driven design is all about. All right. Now in the eighth point, what we have is micro frontend. So microservices are not just about backend servers. Okay, so it's about front ends also. So micro frontend apply the same modularity to UI development. For example, in an e-commerce site, we have orders front end, we have payments front end, we have support chart, we have inventory front end. A lot of things can come. So those all can be independently developed and loaded dynamically into a single page application or single spec. So this enables teams to independently develop the components or parts of the application and deploy it to the production in a seamless manner, right? So the ninth point and the important point, the final important point we have with us is orchestrating microservices effectively. So why do you need this? So you need a control plane to handle deployment, definitely, right? Scaling, networking between services, lot of things are there to handle when you are deploying a microservices based application. So this is where Kubernetes or service orchestrations come into the picture. So your CLI, your web UI, your application, your backend, your APIs, all interact with the shared backend via Kubernetes services. So if a node dies, then Kubernetes reschedules the pod automatically, right? So you don't need to worry about whether my order service is down or user service down, how to scale it, right? All those things you do not need to think about, because the orchestration tool like Kubernetes handles just out of the box. So that's where the built-in resilience comes into the picture. So having orchestration also enables you to have monitoring, health checks, observability out of the box. So that's a very good thing to have orchestration while you're planning to deploy microservices based application. So and there you have it, 9 microservice best practices that can make or break your entire distributed architecture or distributed systems. And which one of these or you have already implemented or you have already experienced or faced it before? Let me know in the comments. And if you have any questions around whatever we discuss in this video, drop a comments in the drop a comment. We'll discuss there. Okay. So if you like this video, let's target for 50 likes for this video, and I'm targeting to reach 3,600 subscribers by the end of this month. So keep supporting. So the one point is you might not need all of them always, but you might need handful of this always basically. All right. Also, I'll request you to check my RGB system design playlist where I'm covering all the system design concepts that is required with the best example possible, real life example possible, with practical applications also. I'm explaining the things. So we'll be covering all the 9 sections in a well structured manner. One by one I'm covering the topic. You can just check in my channel, or you can just search for RGB system design playlist in the YouTube, and you'll land on this playlist. If you are exploring system design, so this playlist is the go-to playlist for you. All right. So that was about today's video. So if you have anything, let's discuss. And thanks for watching this video, and I'll see you in the next one.